we are trying to understand the organization of and the architecture of neurons. And to do that, we're using a lot of advanced microscopy techniques, and in particular, super resolution optical microscopy. We use this to try to understand several key structures that are unique to neurons, and that allows them to have their very unique shapes and functions. What we hope to answer is really to go beyond the static description of the structure. So with the single molecule localization microscopy, we got a great deal of details about the static organization, but you are looking at snapshots of fixed cells. So this is limiting because imagine you want to understand soccer or tennis by just looking at fixed photographs. And of course, it would be extremely difficult. So you will need to have tons and tons of photographs to get a feeling of how the game is played and what is the goal and what each team should do. So right now, what we're trying to do is to get inside from the dynamics of it, how it assembles, how it's modulated, how it's transformed during various events like plasticity, because we are talking about neurons, or pathological events like degeneration and things like that. So basically the dynamic history and from these dynamics, getting hints at function. So we can infer and make hypotheses about the function looking at fixed photographs, but now that we know how things move, we can make much better hypotheses and then test them in a functional way.